So we'll talk about logical functions and selection structures. As you know, the programming usually when you do programming, it could be sequential or selection or repetition. The most important thing that you have to learn at first is the logical conditions, which could be relational or it could be logical. So okay, let me delete this. So this is the online Matlab. So I created a file in here, and let me put it as a comment. So the the programming could be sequential, sequential, or selection, okay, and or repetition. Well, you have repetition structures, okay. We need to learn a little bit about the logical conditions. These logical conditions could be relational, and it could be logical, okay. Logical. So let's talk a little bit about the relational and the logical. So for example, if I have x, for example, equals let's say equals 5, all right, and I have y equals to 1, then I could have relational relation. So I could, for example, check if x is less than y, all right, less than y. So let me run it, and it gave me 0, because x is 5, is more than 5, okay, more than 1. If I do x greater, okay, than y, then it will give me 1, which is suppose, let me bring this up a little bit that you could see. So the first test in here, x, which is 5 less than y, gave me logic 0. 0 means wrong, means false. So this is definitely is false, okay, false. And this is definitely is true, okay, true. True, and true means it gives you logic. The logic is 1. When it's false, the logic is 0. The logic is 0. So in the first test gave me 0, which is false, and the second one gave me 1, which is true. All right. Also, we could compare like matrices. So x, for example, it could be, let me modify it in here, it will be a vector, which is 1, 2, 5, and y, for example, will be, let's say, x, whatever, x minus 4. So the same thing. So this is a vector. I mean, let's run it first. All right. So the x is like 0, 0, 0. Okay, which is, and the y is like the x is minus 4. Okay, so this is like x 1, 2, 3, 4, 5, and the y is like the x minus 4. So 1 minus 4 is minus 3, 2 minus 4 is minus 2, 3 minus 4 gives you minus 1, 4 minus 4 will give you 0, 5 minus 4 will give you 1. Now when we compare x with y, we will say, for example, is x smaller than y? Of course, this is the first one gave you 0, 0, 0. That means false. It's 1 is not less than minus 3, so gave you 0 in here. 2 is not less than minus 2, gave you 0 in here. 3 is not less than minus 1, give you 0, and so on and so forth. However, when we said is x greater than y, gave you 1, 1, 1, 1, 1. That means all true. So when you talk about um, uh, operations. Okay, so you have smaller than, you have smaller than, you have smaller or equal, you could have a greater or equal, you could have a smaller or equal, you could have a smaller, a greater, I'm sure, a greater, you could have equals, okay, equals, and you could have not equal. So all of these are relational operators that you could use in your code, and you need to use them a lot in your programming. All right, so you could go ahead and try them. Let's talk a little bit about the logical operators. So let me go down in here and put like here. So you could have and this is the and operation, and the and operation, okay, and then you could have the not operation. This is the not operation, and you could have also, you could have the or operation, which is like this. This is the or operation, all right, and you could have the XOR operation, XOR operation, which is the exclusive or, and you could have the let me put the comment first. You could have the short circuit, the at we call it short circuit and, all right, and you could have also the or, which is like this, all right, and this is short circuit or the short circuit or all right. So please note that the difference between, there's a big difference when we say, for example, x equals 5. So this, the equals means equals. It equals. In here, when we say x equal 5, it's a completely different meaning. Okay, this is the this is a logical operator. We said a question. It's like a question. It's like a question. Okay, is x equals to 5? So equal is a relational operation. This is an assignment operation. So we assign a value 5 to the x. And here we're trying to find out what is we're trying to check if x equals to 5. So please be aware of that. All right. So let's try like a problem. Let's say that x, for example, let's go modify in here x. It equals, let's say 1, 2, 3, 4, and 5. That's it. This is x. And let's say y. Okay, let's change y to be something like that. Let's make it, for example, minus 2, 0, 2, 4, 6, for example, right? And let's say that z equals, okay, something like, let's say it's 8, 8, 8, 8, 8. So I have 3 vectors, each one has 3 values. Okay, okay, all right, 3 values, right? Let me just for now, comment this, make it a comment, completely comment, and let me make this a comment. All right. All right. So what I'm trying to do in here, if I would like to check if z, okay, greater than y, and all right, and x is greater than y. Alright, and x is greater than y. So what I'm doing in here, I'm having two checks. First of all, I have to check if z greater than y. So 8 is greater than 1, 8 greater than 2, 8 greater than 3, 8 greater than 4, and 8 is greater than 5. So this will give you all ones because it's true. Now I'm checking if x is greater than y. Okay, is 1 greater than minus 2? Yes. Is 2 greater than 0? Yes. Is 3 greater than 2? Yes. Is 4 greater than 4? No. It's equal to 4. Is 5 greater than 6? 5 greater than 6? No. 5. So this part will be false. So the whole operation will be false. Let's run it. So as you see in here, it gave you logic 1. The answer, it should be okay. So it gave you let me just comment this to make it more clear for you. Just a second. Let me comment this. Okay, let me comment this. Okay, let me comment this and run it again for you. Okay, so this is the y, this is the x, this is the y, this is the z, and when I'm trying to compare them, okay, so this is give me 1, 1, 1, and the last two failed. It's a false. So that's a logical. Okay, so you have to go back to your math. What is logical and what is logical or, and so forth. So this is our what you need to do. So these are the relational and relationships that you need to know. Final note in this video, that usually when you try to write a code, okay, usually you start with, okay, let me put it in here, you start with a flow chart, okay, or you could have a pseudocode, okay, which is like English. This is like you write it in your English language, okay, and this is like a graph, okay, that you try to have the procedure for your code, how it runs, right? So I think in your textbook section 8.2 give you some examples how to write the CD code. So go to section 8.2 and please review the flow charts and how to write the flow charts when you try to write the things. Okay, so it's just writing the logic. So for example, let me have another file in here. Okay, another file, whatever is a file. If I need to write a program that converts the miles per hour. If I need to write a code that converts miles per hour to, for example, foot per second, if I have a value. So the first thing I have to do is to create what are the miles per hour. So I could create, for example, mile per hour vector, which equals from zero, and the step is 10 and up to 100. I could put semicolon. I don't want to display it. So I will have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this is like what I'm trying to get. And then I have to write the conversion. So how you convert it? So I need to convert it to foot per second. And foot per second is very simple. You're gonna take the array, which is miles per hours, okay, the vector mile, okay, multiplied by 5,280. Okay, each mile has 5,280 foot, right? And the hour has 3,600 seconds. That's how many seconds in 1 hour. Okay, now out of these two vectors, I could create a table. Let's call it table, right? Okay, and it will combine the two vectors, miles per hour, as one column, and the other column will be foot per second, for example, foot per second. All right, I could display easily. I could display whatever message I want. For example, I could say the message is velocity conversion table. All right, and then after that I could display, let's say this display, you know, the heads of the table, like this. I could have few spaces, for example, mile per hour. Then I have a few spaces, let's say foot per second, whatever. All right, and then I could print the table. So I could use the printf statement, or fprintf, and the first value, it will be a float. I will have 8 spaces. There is no point. There's no values after the decimal point, and the value is a float. The second value, as we learned from please go back to the previous chapters where we explained the printf. Okay, it will have 8 spaces. Let's say 8 spaces, and I will have 2 decimal points, and the value is f. And you know, I will have after each value I'll have n, and the values are coming from table. All right. So again, let's recap. So I need to have like values conversion from miles per hour to foot per second. So I started a vector which has like start with 0, end with 100, the step is 10. Then I wrote the formula for the conversion. Which is like you multiply the miles times each mile has 5,280 foot or feet, and the hour I converted, it has 360 feet. Then I combine this vector with this vector in one table, miles per hour and foot per second. Okay, then I'll try to print that. Let's try to run this. Okay, I have to name it, of course. This means mile per hours, whatever. Let me call it mile per hours. Okay, for example, 2 foot per second. How is that? Okay, let's say it's a good thing. All right, so that's what it is. So look in here what we had, and of course, I mean, always a good habit to do CLC and clear. All right, let's run it again, see what will happen. That's good. So in here did not appear because I put semicolon. Did not appear because I have semicolon. But what will happen? We created a table. So to convert 0 miles per hour, it will give you 0 foot per second. 10 miles per hour will give you 14.667 foot per second. 100 miles per hour will give you 146 foot 0.6667 foot per second, right? All right, and in here there is a mistake I did. So the table here, okay, that's why it's not. So it has to be here, and then the table, okay, like that. Okay, now might work. Let's try it. Here you go. So we created the table. You see in here, this is a little bit shifted because I gave more spaces. Let me go 1, 2, 3, 4, 5, 6. Right. Let's run it again. There you go. It's kind of aligned in here. So these are the results of printed, right? So you could create a flow chart for that, and you could try that out.